students, today we are going to discuss about the next topic called as acids, bases and salts. The first is acids. I think so all of you remember it, the acid, bases and salts. It was a chapter for class 7, I think so. All of you studied this, all the acids and bases. What of information I think so you two are having, if you remember all those points, what are acids, what are bases. Yes, once again we revise all the points. Now we'll start with the acids. What are acids? These are the chemicals when they react with the water, they form hydronium ion. I repeat, when they react with the water, they form hydronium ion. Yes, H3O plus is an hydronium ion. It is a hydronium ion and its formula is H3O plus. Actually, acids, now we'll go for the acids. Classification of acids. Acids have been classified in 3 different ways. I repeat, acids have been classified in 3 different ways depending on their sources. Classification of acids classified in 3 ways. The first one is depending on their sources. The first one is depending on their sources. Second one is depending on their concentration. The first one is depending on the sources, second one is depending on their concentration, and the third point, depending on their basicity. Yes, these are the 3 classifications. The first one is depending on their sources. Second one is depending on their concentration. Third one is depending on their basicity. First, we'll discuss about the first point, depending on their sources. Yes, depending on the sources. Actually, on the sources means where they are available. These are available naturally, these are available artificially. Naturally, we are calling it as organic acids. Artificially, we are calling it as inorganic acids, or it's also called as mineral acids actually. The first one is organic acids. Yes, what is this organic acids? These are available from the fruits or vegetables. I repeat, organic acids, these are available from fruits or vegetable. The basic resources of these organic acids are fruits or vegetables. and they are having the basic element as carbon and hydrogen. The word organic is there, so carbon and hydrogen should be compulsory present in these acids. So only it is considered as an acid. The base element of this organic acids are carbon and hydrogen, and the sources, these are available from the fruits or vegetables. Usually, normally, which are those acids? Oxalic acid is available from the tomato. Oxalic acid. Oxalic acid is available from the tomato. Usually I think so. All of you will have the tomato. Next, tartaric acid will be available from the tamarind. Tartaric acid will be available from the tamarind. Tartaric acid, it is from the tamarind. The third one, citric acid, I think so. All of you are familiar with the citric acid, and this citric acid is available from the basic elements or basic fruit is lemon is there or orange is there. The third one is citric acid. Next one is malic acid. Malic acid is available from the apple. And see here, oxalic acid available from the tomato. Tartaric acid is available from the tamarind. Citric acid is available or present in the orange or lemon. Malic acid is present in the apple. Apart from that, we are having the chemical called as methanoic acid. Methanoic acid, but it is available from the animal actually, the animal source. It is present in the sting of bees or in the animals. Methanoic acid actually. Okay, we'll discuss methanoic acid later on. Yes, this is there. Even the acetic acid is there. Those all are considered under the organic acids, where the basic element is carbon and hydrogen. Okay, these are about the organic acids. Next we'll go for the inorganic acids. Organic acids, these are also considered as natural acids. The second one is inorganic acids. The second acid, depending on the sources, the second acid is inorganic acids. Yes, inorganic acids, these are available from the minerals. These are available from the minerals, and these are also called as mineral acids. Example is the most and the strongest acids will be available in this group only. The strongest acids, the first one is hydrochloric acid, second one is sulfuric acid, then is nitric acid. I think so you all are familiar with these three acids: sulfuric acid, hydrochloric acid and nitric acid. These are the three acids. Commonly, we will consider the only three acids. Apart from that, we are having some more acids. HCl is there, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid. Apart from that, we are having hydrofluoric acid, HF, hydrofluoric acid, HBr, hydrobromic acid, HI, hydroiodic acid. Yes, these are also the acids which comes under this inorganic acids. Hydrobromic acid, hydroiodic acid or hydrofluoric acid. And keep in mind, hydrofluoric acid is stored in the plastic bottle instead of a normal glass bottle. Hydrofluoric acid is stored in the plastic bottle because it highly reacts with the normal bottle or the reagent bottles, and it may create a problem. So only it creates a problem or reaction takes place. So only they use a plastic bottle to store the hydrofluoric acid. And the strongest acids are here only sulfuric acid, hydrochloric acid and nitric acid. These three acids are there. These are the basic acids actually. And I think so all of you are familiar with these three acids. Okay. Next, we'll go for the second point. Second classification of the acids, that is depending on their concentration. Second point is, or second classification of acid is depending on their concentration. What is this concentration? We are having two types of acids there in this group, that is concentrated acid and dilute acid. Concentrated acid and dilute acid. What is this concentrated acid? What is this dilute acid? Actually, every chemical can be concentrated and every chemical will be diluted. Usually, all the chemicals, when they available directly, those are considered concentrated. When we add water for it, it is called as diluted. Very simple. What is this concentrated? The acid which is having no water or less quantity of water, it is considered as concentrated acid. And dilute acid, the acid which is having, second one I am talking about, the second one, dilute acid, it is an acid which is having more quantity of water from its own mass. It is called as dilute acid. Dilute acid means just we are adding water to decrease its concentration level. That is dilute acid. Okay, it is about the classification of acids. Second part, depending on their concentration. Concentrated acid and dilute acid. Next, we will go for the third part or third classification, that is called as depending on its basicity. Depending on their basicity, it is called as, we are having three types of basicities or acids. Which are those? Monobasic acid, dibasic acid, tribasic acid. Depends on how much quantity of hydrogen ions are separating or available or forming from the existing acid. An acid is reacting with the water. How much quantity of hydronium ion is available or formed? On that basis, it is called as monoacidic base, diacidic base, triacidic base. And how to identify it? It is dependent on the number of hydrogen atoms present in an acid. Number of hydrogen atoms present in it. For example, the example is the first example. In monobasic acid, I repeat, in monobasic acid, what happens? Hydrochloric acid, HCl, hydrochloric acid is reacting with the water to form hydronium ion and one more anion. I repeat it once again. Hydrochloric acid is reacting with the water. When hydrochloric acid reacts with the water, it forms hydronium ion. See here, hydrogen is reacting with this water and chlorine is separating. We are getting one hydronium ion. Yes, we have got one hydronium ion. It is called as monobasic acid. Okay. The second one is dibasic acid. To get the what is dibasic acid? Now we are going to get two hydronium ions. Two hydronium ions. How to get two hydronium ions? At least an acid should have compulsory two hydrogen atoms. Then only we are going to get two hydronium ions. For example, the second one is dibasic acid. It is a single word, dibasic acid. The best example, which acid will be having two hydrogen atoms? Usually sulfuric acid, H2SO4. H2SO4 is the formula of sulfuric acid. And now we are going to get two hydrogen ions. Just we'll see it, how it happens. Sulfuric acid is reacting with the water to form H2SO4 is reacting with the H2O to form H3O. Now we have got H3O. One hydrogen from sulfuric acid is joined with the water. Now it has become H3O. Now what remained here? Here we have got HSO4. HSO4, it is a negative, that is anion. Now what happened? Still the hydrogen is remained. So the hydrogen is remained with the sulfur SO4. So I have to remove that SO4. Once again there will be a reaction. Because HSO4 is a negative ion, reacts with the water. Reacts with the one more molecule of water. Now we are going to get the second hydronium ion. And what remains now? From HSO4, H is reacting with the water, remain is only SO4. Sulfate ion. Yes, from this H2SO4 we have got two hydronium ions. So it is called as dibasic acid. See here, we have got two hydronium ions from the sulfuric acid. So it is considered as dibasic acid. And the third acid is tribasic acid. Yes, in this acid, minimum we need 3 hydrogen atoms in an acid. Minimum 3 hydrogen atoms. Which are the acids having 3 hydrogen atoms? One is phosphoric acid, the one more is boric acid. The formula of phosphoric acid is H3PO4 and the boric acid is H3BO3. We'll take it as the phosphoric acid H3PO4. Now, step by step, we have to remove all the 3 hydrogens from the phosphoric acid. 3 steps will be there. 3 hydronium ions will be separated or formed. Phosphoric acid is reacting with the water to form H3PO4 is reacting with the H2O to form H3O plus H2PO4 minus. Now what happened? Here H2PO4, still 2 more hydrogen are remained. We have to remove these 2 hydrogens. Next step. Yes, it is a second reaction because we have to remove step by step each hydrogen from that respective acid. Then only we are going to get 3 hydronium ions. Now, from H2PO4 we have got 1 hydronium ion and H2 was there after reaction, HPO4 is there, 2 minus. What to do? This HPO4, still 1 more hydrogen is remained. Once again, re-reaction. Yes, at last we have got the PO4 3 minus and HPO4 is becoming PO4 3 minus. and we have got 3 hydrogen ions. H3O plus, H3O plus, H3O plus. 3 hydrogen ions from an acid. It is considered as a tribasic acid. This acid is considered as tribasic acid. It is about the third point of classification of acids depending on their basicity. The first was depending on their sources, second was depending on their concentration, third was depending on their basicity. Yes, now we'll discuss about the physical properties of acids. I repeat, physical properties of acids. Yes, we are having 5 physical properties of these acids. Normally we are using 5 physical properties. The first physical property of this acid is acids are sour in taste. Yes, we came for the basics of these acids. Acids are sour in taste. The first point. Yes, these chemicals are sour in taste. Usually we have got this idea regarding from the organic acids, not from the inorganic acids or mineral acids, because those are very dangerous, those are very strong. If even they fall on our body also, it creates a huge mess for our body. So only usually they use the organic acids like lactic acid is their curd. It is sour. If you take about the citric acid, it is sour in taste. If you take about the tartaric acid, it is sour in taste. Okay, on this basis, they told it acids are sour in taste. Okay, we'll discuss about the lengthy point of acids in the next class. Now we'll go for this basics of it, physical properties. Second physical property of acids. Yes. Second physical property of the acid is its pH value. What is pH? pH is nothing but power of hydrogen ion concentration. Power of hydrogen ion concentration. pH. P should be small, H should be capital. Even they will use the word potence instead of power, also they will use the word potence. Power of hydrogen ion concentration in any chemical, acid or a base or a salt. It is only for acid, base or a salt. Okay, and the pH value of these acids is 0 to 7. I repeat, acid is 0 to 7. Yes, 0 to 7. Now it comes 0 to 7. In this we are having two groups. 0 to 2 is strong acid. 2 to 7 is weak acid. strong, which is weak. Hydrochloric acid, sulfuric acid, nitric acid, those all are considered as strong acids. Remaining maximum all the acids are weak acid. It may be acetic acid, it may be oxalic acid, it may be malic acid, it may be tannic acid, or it may be tartaric acid. Those all are considered as weaker acids. Actually, HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, these are considered as strong acids, and their pH value ranges from 0 to 2, and 2 to 7 is remaining these all acids, 2 to 7. And out of these three, hydrochloric acid, sulfuric acid and nitric acid, which is more stronger? Actually, even the sulfuric acid is considered as king of chemicals. Still, hydrochloric acid is considered as a very strong acid. I repeat, hydrochloric acid considered as strong acid. Its pH value is 0.1. The pH value of hydrochloric acid is 0.1, and the pH, what is the pH value of sulfuric acid? It is 0.3. The number is lesser, the chemical is stronger, the acid is stronger. Sulfuric acid H2SO4 is 0.3, nitric acid is nearby 1 is there. Nitric acid nearby 1 is there. Hydrochloric acid 0.1, sulfuric acid 0.3, nitric acid 1 is there. Even there is an acid present in our body. I think so all of you know about it, because our body itself is an acidic. The base of our body itself is acidic. It is called as DNA and RNAs. Deoxyribonucleic acid and ribose nucleic acid. The base of our body, DNA itself, is an acid. It comes in the part of what you call it as a cell. Inner part of the cell, inner part of the nucleus, we are getting the DNAs, and this DNA itself means our base of the body is acidic. DNA, every part of our body we are having acids, deoxyribonucleic acid. Even one more acid is there, the more stronger acid in our body, that is hydrochloric acid. Hydrochloric acid is present in our stomach. Actually, this hydrochloric acid will kill the microorganisms. It kills the microorganisms which enter by through the food or any other means. Usually by through the food only. Because it is present in the stomach, the food matters will enter the stomach. By through the food only, when microorganisms will enter, they will be killed by this hydrochloric acid. But its pH value is not 0.1. Its pH value is 0.9 to 2.0. It ranges actually. Increases, decreases, increases, decreases. It will be there. 0.9 to 2.0. It is a acid present in our body. Range will be different. Okay. We'll discuss about these all topics in the importance of pH value in everyday life. Okay. Keep in mind, HCl pH value is 0.1. Very stronger acid. Actually, when you go for the first PUC or second PUC, you will be having the practicals on the titrations. Strong acid versus strong base. The base will come next automatically. Strong acid. Which is a strong acid? Usually they use hydrochloric acid. Which is the weak acid? They use acetic acid. The strong acid is hydrochloric acid. The weak acid is acetic acid, which is used in the PU colleges or 11 and 12 for the titration experiment. Okay. HCl present in our body is 0.9 to 2.0. It will be changing, varying due to the consumption of different material or different types of foods. Okay. The next point. Okay. The third point is it will changes. These acids will changes the color of the indicators. These changes the color of indicators. Indicators. What are these indicators? Actually, indicators are the chemicals which are used to identify the given chemical. It is an acid or a base or a salt. Usually acid and base will be identified very easily. Acid, base or neutral. Indicators. We are having multiple indicators, and in acid medium, which indicator, water and which color will be changed, we'll see about it. The first indicator is litmus solution or litmus paper. Litmus. The third point is changing the color of these acids changes the color of indicators. Litmus is a chemical. When you put the acid in the litmus solution or when you dip the litmus paper in an acid, the color will change. Which color? The blue litmus will be changed to the red. Yes, I repeat, the blue litmus changed to the red. Okay, but keep in mind, one chemical is there. One chemical which changed to pink. It is nothing but carbonic acid. I think so know about the carbonic acid. Actually, it is an acid which is used in the soft drinks. I repeat, carbonic acid, H2CO3. Maybe you have studied about this H2CO3 in the class 8th, the chapter called as coal and petroleum. There is a question regarding that reaction. What happens when water is reacting with the carbon dioxide, I think so. And the answer is H2O plus CO2 will give H2CO3. So we are getting that carbonic acid, it will turn to the pink, not to the red. Exception is only carbonic acid, which will not turn to red, turn to pink. Second chemical is methyl orange. Second indicator. The second chemical is methyl orange. In the acidic medium, it turns from orange to pink. See, the word is itself orange. So the methyl orange will turn to the pink. Orange to pink. Okay, it is about the second indicator. The third indicator is phenolphthalein. I repeat, phenolphthalein. Yes, the third chemical is the phenolphthalein. It is usually colorless and it remains colorless. It doesn't have any color. It is a normal, like it looks like a water, colorless, and it remains colorless only. There is no change color of this phenolphthalein in the acidic medium. Okay, the fourth point or the fourth chemical is it is a natural indicator. Already litmus is there, and methyl orange and phenolphthalein, these are artificial indicators. Now we'll go for the one more natural indicator. It is red cabbage extract. Red cabbage extract. Yes, this red cabbage extract, it remains red color only. It will not change the color. No change in color. It remains red only. Yes, This is the point number 1. All the acids are sour in taste. Second, its pH value. The pH value of the acids are 0 to 7, where the pH power of hydrogen ion concentration, and 0 to 2 you are having strong acid, and 2 to 7 is weak acid. The more stronger acid is hydrochloric acid. Okay, and these acids will change the color of indicators. These changes the color of indicators, where litmus changes from blue to red except carbonic acid. Carbonic acid will turn to the pink. Next is methyl orange. It turns from orange to pink. Third one is phenolphthalein. Phenolphthalein will remain colorless. And the fourth chemical is red cabbage extract, and it remains as usual red only in the acidic medium. Yes, we'll go for the fourth point. The fourth point, or the fourth physical property. These acids are highly corrosive in nature. Yes, these acids are corrosive in nature. When they fall on the skin may burn. Not may burn, it will burn usually. Usually, these are from the inorganic acids, or strong acids actually. Which are those? HCl, H2SO4, or HNO3. Maybe you have watched the multiple movies where they show that acid victim will be having a different color, even the whole skin will burn. These acids are very, very dangerous. HCl, when it fall on the body, the color of the skin changes to the umber color. Yes, in the H2SO4, sulfuric acid, when it fall on the body, the color of the skin changes to the black. And when nitric acid falls on the body, the color of the skin changes to the yellow. Yes, these are the three acids which are very, very dangerous, and when it fall on the body, the color of the skin will be changed. HCl, hydrochloric acid, umber color, sulfuric acid, black color, and the last one is nitric acid, it is yellowish color. The last point of this, the last physical property is acids are strong electrolytes. These are good electrolytes. Yes, they produce the electricity in the aqueous solution. I repeat, these acids, especially when we talk about this sulfuric acid or other acids, they produce electricity in the aqueous solution. These are the points of acids, the physical properties, and we have discussed about the classification of acids and physical properties. In the next class, we are going to discuss about the chemical properties and uses of acids. Thank you to all of you.